Hello guys, and welcome to another episode of Introduction to C++ with me, George Wulfers. Okay, so the last tutorial we went over with was tutorial number 3, and it was about constants and operators. Well, first of all, if you guys are following along, you would want to go into my GitHub repository and download the newest version if you have not done so yet. We'll be starting from here. All you have to do is click on this download link and unzip or clone this to your PC or laptop. Okay, so let's get started. Let's see, I have this. This is going to be the agenda for today. And the first thing I want to do is I want to thank Peter Olin for pointing this out, which I don't think I went over last time. And he says A is less than or equal to B is not the same as A equals A is less than to B, as one could easily think after seeing the explanation about the minus equals operators. And this is true. And I want to thank him once again for pointing this out. So before we get started, I want to clarify this. So we said earlier, or last time we were here, that A I was going to do the other one, minus equals B is the same as A equals A minus B. And these both are integers. Let's just do this. And let's say A is 10, or I don't know, 2, B is 3, or 1. So the result of this would be 1. Or let's say 5 and 6, or 4. No, 5 and 2. So we can get other than 1 or 0. So that'll be 3. And now these are relational operators, or I guess sometimes conditional. I'm not really sure about the naming, or about what they are actually called, but when you use these, it is when you use these, you are comparing two values. Okay, you're not doing arithmetic or assigning anything to any other value. So the only places you would use these would be in if statements, in the condition right here, like if A is less than or equal to B, blah blah blah, right? Or in a for loop, or in a while loop, which we will go over, or a do loop. Okay? This is pretty much where you will use these. And if you do this, since these are comparison, you're comparing, well, since this is a comparison operator, and you are comparing A to see if A is less than or greater than B, since A is 5 in this example, and B is 2, if you do it like this, it'll return either a 1 or a 0, which is true or false. And in this case, it'll be false, because 5 is not less than 2. So A will be equal to 0. And if you're trying to track, some data, like an integer in A, and then all of a sudden, you make it 1 or 0, that's not a good thing. Usually you would, do these in booleans, like result equals A is less than B. Then this would be a more valid sentence, or however you want to call it. And then B, or result, would be false. It will hold this value, or 0. Okay? So don't use these how you would use these when doing arithmetic, because you will lose your data. I hope this clarified. If you guys want to see exactly what happens, let's say A is 5, B is 4, or 2, like the other example, and let's say A equals A less than B, and let's just say that as well. And we'll do a print format to see what's inside of A here. Here, A will not be changed. It'll keep on being 5. But if we do it down here, it'll become a 0. Oh, what do we do? Error A redefinition. Okay. Let's forget we already have those. So as you can see, A on the first one, which is A is less than equals to B, is this right here, the first one. I should really format these better. I'll double space them or whatever. So now we can see clearly that the first thing doesn't take effect. It doesn't do anything to A. Okay? It just gives us 5 because we are comparing these two. We're not doing any arithmetic or anything like that. On the other one, since we're saying A equals A less than B, or we can even say less than equals to B, and we run it again, this thing lets us, it'll be the same outcome. 5 on the first one because nothing changes, no arithmetic happens. And since we are saying A is less than B, or less than equals to B, since that's not true, we put a 0 pretty much, because this is the assignment operator. We're saying whatever this condition is, we want to assign it here. That's what that line of code is saying. But this one is not saying that at all. Okay? So there you guys have it. Hopefully it makes sense. And now let's move on. And once again, Peter Olin, I believe that is his name. Thank you. Okay, next up is for loops. So today we're going to be looking at loops and functions. And these are all of the loops that I will be covering. So we have a for loop, which we have seen that before. We have a for each loop, which is similar to a for loop. We have a while loop. We have a do while loop. We have jump statements, which is kind of like if you have ever done basic language does this a lot. Switch statements, which is kind of similar or the same as saying if, else if statements, but in a different way of writing it. And then we'll go over functions if we have time. So let's go back to our code. I'll save those changes. I will go in here, right click, go to add new project, and let's go ahead and copy that header over here. Copy. Let's go empty project, paste, and make sure we get rid of these spaces. And let's create it. Okay. I will add a main file. And I will go here, copy that header file, paste it here. I don't think I've ever changed the date on this thing. Today is the 9th, and we are going to copy this thing again and paste it right in there. Blah blah blah. Okay. So I guess I should start filling up this description right there. Okay, so we start with the same thing. We're going to be using IOStream today, and another thing we call strings. So we're going to include the string file into our project. And well, strings are just sentences, like I've said, like multiple words. It's a multiple characters. That's what a word is, or a sentence. So that's what a string is. And we're going to be saying using namespace std. This is very helpful since the print functions and like the cout and whatever are part of this, the standard library, and the string are part of the standard library. They are all encapsulated in namespace called std. So if you want to use string, let's just call it name for now. See that it gives us an error. It's because we have to specify the namespace first, and then we have to do colon, which this is the scope operator. And we'll talk more about scopes when we get to classes and stuff like that. It's just saying that string is part of the standard namespace. So that's how you do it. And if you don't want to use that because it gets kind of annoying to keep on writing it over and over again, you can say using namespace std, and we can get rid of that right there and call it like a regular type. Okay, so that's that, and we'll get rid of that for now. So let's see, so for loops. Okay, so the format of a loop is initialization, then followed by colon, condition, colon, and then increment or decrement, or whatever you want to be doing. And then here's just a code block to do stuff. And loops are very useful. They're used in every single program that repeats several functions over and over again. Like, you know, a calculator has every program that we use nowadays have loops, so we can keep on repeating everything pretty much. Games have loops to keep on rendering and getting input from the user and moving your player around and whatever. Without loops, your program is linear, so it goes from top to bottom. Without loops, you would just run your program once and that'll be it. So yes, we use loops a lot. So these kind of loops are useful for traversing through arrays like we have done before, like over here, how we went through this array to print out the float values, which we just saw 0, 0, 0, but yeah. Loops are useful for, having a timer, pretty much. Like you could count from here, from 1 all the way to like n numbers. So let's do that. Let's just say, let's make a for loop. So for. So the first thing is the initialization. So we have to initialize a number or a variable and make it and initialize it to the starting point that we want to start from. So, like int I equals 0. Okay? So, we're going to be starting from 0, and I is going to be our index. The next thing we do is the condition until the condition is as long as this is less than something or greater than something, we'll keep looping. So let's say we want to do 10 numbers, or yeah, 10. We would do this. So this is saying that as long as I is less than 10, we're going to keep looping. And then we increment or decrement based on whatever we want to do. So here we'll just do that. And let's add a space. Okay. And we'll run it. Wait, damn it. Sorry, I forgot to set this guy as the startup project. Okay, now we can run it. And we'll see just counting from 0 all the way to 9. Okay. So that's a loop. We can even do it. Let's do it that many times. No. Just do it 1, 2, 3, and 1,000 times is okay. And now you'll see all kinds of numbers from 0 all the way to 999. So that's what this is for a loop. And you're not limited to just one index per loop. You can actually have more. So maybe we can say that I is 1 greater than, j starts at 1 greater than I, and j is less than sure. And then we'll do j++. And we'll do j. And we'll see what happens. Oh, something happened. Oh. That's because we do not need that again. And as you can see, it starts as 0, then 0, I is this guy, j is the second guy. So it's 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, and so on until we get to 999. So usually, when we have for loops, we usually don't do this. We usually have something called a nested for loop, which is a for loop that is inside of another for loop. Now, this one is going to run in squared times, since for every one of these we'll run the whole thing of here. Well, it'll be true if it would start here, then it would be this. So you can see it. We'll do 1, and then 0, and then 0 through 99, and then 1, and then 0 through 99 until we get, all the way there. So you can see this one takes longer because you're running for every index of I, you're running it 1,000 times. So this is running, since both of these are 1,000, the complexity of it would be like that, which that is 1,000,000 times. So yes, it'll probably take forever. So this is called a nested loop. Also, careful when you're using loops, because if you do something like, let's say, something that will never reach this, well, this one will, but let's say something else. I don't know, you want it to loop until I is less than negative. That, well, yeah. So this one will run forever. Well, I guess it was. There you go. This one's going to run forever because since I is incrementing, we are never going to reach this. And as you can see, we are already in the 63,000s. So careful, because you can introduce, you can kill your computer if you're not very careful, depending on what you do. Or, crash your computer. So, next one. That was the for loop. Now the for each loop. And I call it for each because it's similar to C#'s for each loop. So this loop has the for as the for loop, but instead of having 3 parameters, places where you can put your parameters. This one only has 2, and it's got not sure how to call it. I guess it'll be, I don't know, object colon and container or something. And then you would have do stuff here and blah blah. So this one, let's say we have a string and we're calling it name, and it's going to be holding, this is a string, okay, and we can do this. Car C in name, and we can just say, I don't know, C out C, and let's space it out. And this one should do a print function if it works. And as you can see, well, let's do this and run the other one. So as you can see, we did a for loop and we printed out the string that was inside of name, which was this is a string, and we spaced it out with this line of code. So what you can do is have a for loop where you get the whole bucket and take pieces from the start to the end within that bucket and do stuff with it. You know, like we're extracting one character from here. So I don't know, we can change all the characters to, let's say we want to make sure that everything is lowercase, right? So we'll say if C is greater or equals to A and C is less than capital Z, then we want to do C plus equals 32, and then we want to do a C out of C, and we'll run it. We gotta do that and then run it. And as you can see, here on this string, this version, the first letter is capitalized, but here we made it all lowercase. So there's a lot of stuff you can do with these things. So as we said before, this is a for each loop. So here it's kind of saying for each character in name, then we modify each character that is capital. So that's a fun and dandy thing to have. So let's comment that. What's the next one? So we have done these two. Don't want to save. While loops. before we continue, we usually use these in, let's say you have like an array or a container of different objects, and like game objects, like several little tiles you want to, or meshes you want to render to the screen. You would have them all packaged in, a vector or something like that. And then you would say for each game object within objects, and then you would, draw each one or whatever. So that's something you can do as well. So let's do actually, why is this down here? I don't know. But we're going to do a while loop. A while loop is right here. So the keyword is while, and then here we have conditions or condition, whichever one you want. And then we do more stuff here. Do stuff here. Okay? So let's do this. Bool is running equals true. So while is running true, do this while is running is true. So that's what this is doing. And I don't know, let's just say, let's have a counter again. Count, or int count equals 0. Count plus plus. And we'll just say cout. Okay, so this, and don't forget, with this one you have to specify if you have a boolean here, and if it's true and you're saying you want to run this while loop while it's true, then you have to explicitly tell this loop when to get out. So let's say, if count is greater than 100, we'll break. Okay? This keyword break means get out of whatever loop or statement you're in. There's also something else you can use called continue, and return or whatever you want to use. This one will stay in the same function and just exit and go over here. What this one is going to do, if we say continue, is going to go back up here and continue running the loop. It will not take you out of the loop. This one will not. If this one is called, then it will exit the function. So let's run it, and we should see 100, well, 101 if you count the 0 numbers. There's other stuff you can do. So instead of saying while equals true, if we don't want to micromanage this thing, we can say while count is less than 100, and it'll be like the for loop we had. So you'll go from 0 all the way to 99. Okay, so that's that. Now do while loops. These are similar to while loops, but they're structured a little bit different. So first you say do, and then you do stuff here, and at the end you have while condition. Another thing about while loops, these are usually the loops we have within games, or any, I want to say, yeah, within most programs your loops are going to be while loops, like the main loop of the program where you run all of your logic and stuff. Most of the time, if not every time, it's going to be a while loop, at least for mine. And for almost every code that I've seen, they all have while loops as their main loop. And we'll talk about that later on as we go further deep into the programming realm of awesomeness. So this is the structure of the do while loops. Let's say, let's do that same thing. Count, do, and we'll do another count while count is less than 100. So this will have the same effect as the while loop, which to be honest, I don't really see the difference. The only difference is that you check last the condition, like you do the code block first, and then you check the condition at the end, and if it's true, then you'll do another round here. But I honestly I've never used the do while loops. I've always just used while loops, since they're just more straightforward and easier to read, I think, than these do while loops. So those are that. You can do the same thing with both. So it's, I guess, user preference. So that's that. Do whiles. What do we have next? Jump statements. These are fun. So let's say you want to have a loop, but you don't want to use, for some reason, these things. Now, in assembly language and basic language, these are used a lot instead of using functions, or I think yeah, instead of, maybe not instead of using functions, but instead of using loops, we can do jump statements, which the first thing we want to do is we want to have a jump statements. we want to define a label to let the program know where to jump to. So let's call it, oh no, loop. So this is our label. Make sure you have the name you want to name your label and then colon at the end. This will, the compiler will see this, or the program, and it'll know where, I guess, in your program that thing is. And then we have this keyword called goTo, and you just specify the label. Oh, I didn't call it label, I call it loop. Just like that. And then you can have, like, let's do the same thing, the counting. Let's say if count is less than 100, we'll do that, right? And if you guys want to make sure, damn it, it reads better, we'll just put it instead of code block in there. Otherwise, we're just going to do cout count plus plus, boom, and we run. Okay, and this will have the same effect. Starts from 0, goes all the way to 99. So you can have multiple you do have multiple ways of doing the same thing. So you can use a for loop. You can use a for each loop. You can do a while loop. You can do a do while loop, or you can do jump statements like they used to do back in the olden days. Well, they still do, because people still use assembly. So yeah, I mean, if you want to ever go back to your top of your function for some reason, you can have a label here called start, and I don't know, maybe a label called here exit. That's how we used to do it. And whenever you want to go somewhere, you just say go to and then the label. This is, loop label. This is exit label. So let's say we want to skip this thing. We don't want, we don't want to pause the program. So we'll just call our exit label, and you'll see that it'll loop and then it'll close because we jumped it because of that. So yeah, there's pretty cool stuff you can do with C++. So that's that. Pretty straightforward, I think. If you guys have any questions, damn it, why do I always try to save? I do not want to save. But it's a good thing if you guys save. You should always save, except these notes. Anyway, if you guys have any questions about these, don't hesitate to ask. If I am missing something, I would appreciate it if you guys would let me know, and please and thank you. So let's go ahead and actually right here, we'll go into switch statements. So switch statements, we usually use these to kind of like parse input, maybe. Like, let's say you have a menu or something, and you want to see what the user got, the user inputted. So what we could do is we have an integer, and we'll call it, oh no, input. We'll set it to 0. And then, this is another thing. This is how you get input from the user. We're going to do it right now. First, let's do a printf. And let's tell the user to input any number, please. Right? And then we do cin, and then we want to use the right shift operator. Is it? Yes. And then we want to specify where we want to store that input. So we want to store it in here. And then when they're done, we can do a switch statement and pass input as our condition or variable that we want to check. And then we simply do case 0, case 1, two, and default. Okay, and let's say here we'll just do printf and say your number is 0, and then maybe here 1, and then 2, and then here we do whatever. So what this will do is we have 3 different cases of what the number could be that we want to process information for. So if the input is 0, we're gonna print to the screen your number is 0. If it's 1, then we're gonna say 1. If it's 2, then we're gonna say 2. If it's anything else than these, we're gonna say that. Okay? So let's go ahead and run it. Okay, and then it says input any number, please. Okay, let's do 0. Okay, we just got out of the program. Okay. Let's do another cin, right? No, it'll probably not work either. Cin that, what was it? There was a way to flush. Was it flush? O-stream? No. Oh well. There was a way that you could flush any unwanted input, but I do not remember what it was. So we'll just do the system pause right there. Okay, so we do 0, press enter, and it says your number is 0. Press anything to continue. Let's run again. 1. Your number is 1. If it's 2, it'll say your number is 2, but let's do anything other than 0, 1, or 2. Let's do 5. And your number is whatever. So there you go. Make sure that whenever you're writing these, you want to always make sure that between cases, at the end of each case, you have break. If you don't have break, like let's say you have it like this, and you think, oh, just because it's spaced, it'll not run this one when I don't want it to. But the reality is, when let's say input is 0, if we don't put a break here between 0 and 1, then this one's going to get executed, and then this one is going to get executed as well. And then if we have break here, it'll get out of this switch statement. So remember, I'll show you so you don't think I'm lying. Okay, so let's say 0, and there you go. Your number is 0, your number is 1. But if we do break, and we do 0 again, we will only see the first output that we wanted. So make sure you put break after each case to make sure you get out of the switch statement. Okay? Now, there's other stuff you can do with this, like let's say you have a string. You can do string here, like check to see if it's something like that, or like maybe A to see if someone chose A or something like that. We will be using this a lot. This is kind of like a different thing about you could easily replace this switch statement with if else, or if else if else if else statements. But sometimes, I don't know, I guess readability wins. I don't know, I think you can read this a lot better sometimes than these. And these are they're usually just for like comparing or checking to see if the contents of a variable match any cases like this. These we usually use these when we are doing keyboard input or checking messages, like in Windows API. You have Windows procedure, I think it's called, WinProc, and that's where all the messages get sent to, and you can process all the messages that the operating system sends you or that the user sends to the program to do special tasks or whatever. You will need, if you want to do games, you will definitely be using these. And when we get more advanced and start looking into video game stuff, we'll definitely be doing these with keyboard input and possibly menus. I sometimes I like to do my menus like this as well, but user's preference, I guess. Okay, so that's that. Okay, let's see how far we've gone. Okay, so it's about an hour into it. We'll actually continue next time with functions. How to declare a function, different return values of functions, parameters of functions, like different parameters, referenced versus not referenced, inline functions and what they are, and recursive functions, which are pretty cool once you get the hang of it. Okay? If you guys like these tutorials and would like to see more, don't feel free to subscribe. If you guys have any questions, comments, or concerns, please don't hesitate to either comment below or send me a message with anything that you guys want. If you guys have any requests, feel free to let me know, and I will try my best to get your requests in and do a video on those. If we do not have anything that I first want to do, I will definitely write a list about it of those things. Okay. Don't forget to go to GitHub. There should be a link down there in the description with my link to my repository to download the newest video stuff that we did here. It'll be up there as soon as I'm done recording this. Okay. So yeah, hope you guys had a great weekend and have a great week ahead. I'll probably be back again tomorrow, maybe later on today if I feel better, because I haven't really slept much. And it's already 8:35. So yeah, feeling kind of drowsy a little bit. All right. Well, you guys have a great day. See ya.